Hi my dear friends, welcome back to our YouTube channel. This is your ADC Maths. In this video, I am going to introduce how to find the nature without reducing them into the canonical form. Actually, we will get the nature with the help of canonical form. The canonical form is nothing but in terms of the eigenvalues lambda 1 y1 square plus lambda 2 y2 square plus lambda 3 y3 square. So with the help of these three, lambda 1, lambda 2, lambda 3, we can easily determine the nature of the given quadratic form. But this time I don't want to find any eigenvalues. So without converting them to the canonical form, lambda 1 y1 square, lambda 2 y2 square plus lambda 3 y3 square, I already made a separate video how to reduce the given quadratic form into the canonical form. Please go and watch. Yeah. Now, what is the procedure to determine the nature of the given quadratic form? So actually the quadratic form Q can be given in terms of x transpose AX, where x is the column variable matrix x1, x2, x3, etc., xn. If I am considering the three variable case x1, x2, x3. And what about the A? A is the real symmetric matrix. A is the real symmetric matrix of order 3 by 3. Right? So how to convert this quadratic form or how to get the nature of this quadratic form without converting them into the canonical form. So that's a procedure. Very simple concept. As I told you that it's a 3 by 3 matrix and the variable set is x1, x2, x3. Then probably the real symmetric matrix x1 is, there is A is nothing but A11, A12, A13, A21, A22, A23, A31, A32, A33. So this is the 3 by 3 real symmetric matrix of the given quadratic form Q with the three unknown variables. Now I am going to determine the principal minors. What the principal means? Principal leading diagonal elements A11, A22, A33. So with the help of these three diagonals, I am going to introduce three determinant values. One is, the first one is called the D1. It is D1 is nothing but the first principal determinant with the help of through the first diagonal. And let us extend for the second diagonal up to this. So I get the 2 by 2 matrix, that is A11, A12, A21, A22. This is called D2. This is called second principal determinant. Is often called as second minor, principal minor. If I extend the third one for the third diagonal element, it's called D3. So D3 is nothing but the determinant of the matrix A. So let's see the procedure. Let capital A is equal to Aij of n by n with the given real symmetric matrix of Q, that is the A. To determine the D1, D1 is the first principal minor, that is only the first diagonal elements A11. It's a determinant A11. D2 is the 2 by 2 determinant, that is first and second principal diagonals can be included. That is A11, A12, A21, A22. And the D3 is nothing but all the three diagonals can be included. That is called the D3 is the third principal minor of the given quadratic form Q. That is A11, A12, A13, A21, A22, A23, A31, 32, 33. So this is exactly the determinant of the given matrix A. Find out D1, D2, D3 value. So where D1, D2 and D3 are called the principal minors of A, is often called as principal determinants of A. Principal determinants of A. Why it is called determinants? Yeah, this we are going to find the determinant value through the principal diagonal elements. A11 first, then A22, then finally the A33. So this is, we can extend 1, 2, 3. So D1, D2, D3. Now, how these three values will help us to determine the nature? Isn't it? A very simple concept. Once we got the D1, D2, D3, because it's a 3 by 3 matrix, it's a 3 unknown variables. So once we got these three, with the help of D1, D2, D3, we get the nature. Normally, the nature can be classified into 5 types. Let us see one by one. First one, the nature of the given quadratic form Q is positive definite. Positive definite. It is countable, it is measurable, it is well defined. So positive definite means D1, D2, D3. What is D1? This one. D2, this D3. D1, D2, D3, all are positive. All are positive. That is Dn strictly greater than 0 for all n value. N equal to 1, 2, 3. All are positive, positive definite. When we say that the nature is negative definite, negative, then minus 1 fold power n include with the dn. Minus 1 fold power n, dn is always positive. If n equal to plus 1, what happens? This becomes minus d1 equal to 0. So minus d1 is positive means what about d1? d1 is negative. If n equal to 2, this becomes it is minus 1 fold square d2, it is positive. That means minus 1 fold square is plus 1 is, so d2 is also positive. When n equal to 3, we get it is minus 1 fold power 3, d3 is positive, but minus 1 fold power 3 is minus, so minus d3 is positive, that means that d3 is negative. So the odd values d1 and d3 is negative and d2 is positive. In generally, minus 1 fold power n, dn positive for all n, then we get the positive definite. d1, d3 is negative, negative definite. If d1, d3 is positive, d2 is also positive. All are positive, positive definite. If the d1, d3 are negative, then d2 is positive, it is called negative definite. Positive semi. Semi in the sense at least one value is 0. Among the d1, d2, d3, at least one value is 0, others two must be positive. So that's why it is given dn greater than or equal to 0 and at least one value is 0, at least one. Among the three, one is 0. Other two are positive, is called positive semi-definite. Okay, the same way, at least 1 0, but minus 1 fold power n dn is greater than or equal to 0. Minus 1 means what's mean that? d1 and d3. So d1 and d3 are negative, d1 and d3 are negative, and the others are positive. That's others are 0. d1, d3 is negative, and at least one is 0. Then it is called semi. So this is the negative, so it's called negative semi-definite. So semi in that sense, at least any one value is 0. That's mean that's semi, right? If d1, d3 is positive, d2 is 0, or d1, d2 is positive, d3 is 0, it is called positive semi-definite. At least one is 0, other two are negative, is called negative semi-definite. All other above cases, it does not exist. Apart from all the above cases, apart from all other cases, it is called indefinite. Indefinite means we cannot say anything about the nature. Indefinite. We cannot say anything about the nature. So that is a case of indefinite. Understand? Clear? Now let us see the problems. I have considered 4 problems for your better understanding. The first one, Q is equal to x1 squared plus 3x2 squared plus 6x3 squared plus 2x1 x2 plus 2x2 x3 plus 4x3 x1. Now find out the real symmetric matrix. Real symmetric matrix of 1. So I am going to the first question now. So see that the first one. What is the real symmetric matrix of A? I think so. First of all, we can fill it up the square values, the coefficient squares in the diagonals 1, 3, 6. What about x1, x2, 2? So it is by 2, 2 by 2, 1. I made a separate video how to convert the quadratic form into the real symmetric matrix, how to convert the symmetric matrix to the quadratic form, vice versa. Both. Please go and watch a separate video. So this is my x1, this is my x2, this is my x3. Here this x1, it is x2, here it is 3. So what about x1, x1 squared? So x2 square, x3 square, is right? Now x1, x2 where we get x1, x2 here. So the coefficient is 2. It is symmetric. So we divide this by 2, we get 1, 1. What about x2, x3? x2, x3 where we get x2, x3? x2 and x3 here. x3 into x2 here, symmetric matrix. So these two places. What's the answer? Minus 16 is the coefficient. Half of the coefficient is minus 8. So minus 8, minus 8. So this is the x2, x3 coefficient, right? Yeah, I think this is the first question. Yeah, there is 2, no. So x2, x3 is 2 once again. So it is plus 1. Plus 1. What about x3, x1? Where we get x3, x1? x1, x3, x1, x3. So these two places. The coefficient of 4 is, that is x1, x3 is 4. So 4 by 2 is 2. So 2, 2. So this is the real symmetric matrix of the given first quadratic form. 1, 3, 6 in the diagonal. Half of the coefficient of x1, x2 is here, 1, 1. Half of the coefficient of the x2, x3 here, and half of the coefficient of x1, x3 is here. That's right. Symmetric matrix is clear, very clear. Now can you determine what is a d1, d2, d3? What is the meaning of d1? Yeah, d1 is called the first diagonal value. So 1. So 1, 1 is positive. That's right. What about d2? d2 is equal to determinant of 1, 1, 1, 3. We extend the up to the second diagonal. So 1, 1, 1, 3. The answer is 3 minus 1 is equal to 2. So this is also positive. So these two are positive. Now d3 only, the final one. This only decide what about the nature. What about the nature? So what is the d3 here? So mod d3 is nothing but the exact the determinant of the matrix A. So determinant of A equal to, as already you know, this is plus, this is minus, this is plus. So 1 into 3, 6 are 18, 18 minus 1. Minus 1 into this row and this column is eliminated. So 1 into 6, 6, 6 minus 2. Finally 2 into this column, this row and this column is eliminated. So 1, 3, 2, 1, 1 minus 6. So 1 minus 6. So what is the answer? Is 1 into 17 minus 1 into 4 plus 2 into minus 5. So the answer is 17 minus 4 minus 10. Anyhow, 17 minus 14 is equal to 3. It is also positive. Please see that d1 positive, d2 positive, d3 positive. I don't know the value. I don't want the value. I need whether it is 0 or positive or negative. Only these three cases. So once d1 positive, d2 positive, d3 positive, I think so d1 positive, d2 positive, d3 positive, all are positive. Then what's the nature of the first quadratic form? It is called the positive definite. So this is the nature. The nature of the quadratic form. The first one is positive definite. It's clear? Understand? Now see the second one. The second one, 5x1 squared plus 5x2 squared plus 14x3 squared plus 2x1 x2 minus 16x2 x3 minus 8x1 x3. So let us go for the same pattern. What is the corresponding real symmetric matrix of the given quadratic form 2? First of all, fill up the coefficients of the square term. So 5, 5 and 14, right? 5, 5, 14. What about the coefficient of x1, x2? 2. So it is a 2. So half of the 2 is 1. So 1, 1. The coefficient of x2, x3 is minus 16. So half of it is minus 8. Where we get x2, x3? x2, x3 here, x2, x3 here. So we put here minus 8, minus 8. The last one is x1, x3. The coefficient is minus 8. So it is minus 4, minus 4. Now find the d1. d1 is the first one. So modulus of determinant of 5. So 5 is positive. So we don't bother about it. What about the d2? d2 is the extension of this one. So it is 5, 1, 1, 5. So once again it is 25 minus 1. It is equal to 24. This is also positive. So we get 2 positive. So what about d3? d3 is very important. What about d3? d3 is nothing but the determinant of the matrix. So once again this is plus, this is minus, this is plus. So 5 into the corresponding row and this column is eliminated. So 5 into 4. 5 4s are, it is 70 minus of minus plus, so 64. Right? Then this is minus 1. So minus 1 into this row and this column. 1 into 14 is 14 minus 4 into minus 4, minus it is plus 32. So it is obviously minus 32 only. Then finally it is minus 4. So minus 4 into 1 into minus 8 is minus 8 minus of minus plus 20. So what's the answer? The answer is 5 into 70 minus 64 is 16. Minus 1 into 14 minus 32. How much? It is 16, 18, minus 18. And the final one is minus 4 into 12. So what's the answer? 5 into 6. 5 6 are 80 plus this much how plus 18, this is minus 48. So what is the answer? The answer is always is positive. So this is also comes under positive category. This also comes under positive category. So all the D1, D2, D3 it is coming positive. Can you check what is the answer? 5 1 minus 4 1 5 minus 8 minus 4 minus 8 14 minus 5 minus 4 14. So I think 5 into 70 minus 64. How much? 70 minus 64 is only 6 only, no, is right? So only 6 only. So 5 6 are 30. Yes, correct. So 30 plus 18 is 48. 48 minus 48 is 0. So I found that the D3 value is 0. So 2 are positive, but 1 is 0. So what we say that 2 are positive, at least 1 is 0. At least 1 is 0, others are positive, then this is comes under positive semi-definite. So the second one is the example for positive semi-definite. So this is the way to determine the nature of the given quadratic form with the help of the real symmetric matrix without converting them into the canonical form. Let us see the third one. The third one. Here the variables are x, y, z. Here the variables are x, y, z. Here the variables are x, y, z. Let us see that x, y, z, x, y, z. So how to get the determinant? That is the real symmetric matrix. 2x squared plus 1y squared minus 3z squared. What's the coefficient of xy? It is 12. So we get xy here, x into y here, x into y here. 12 by 2, 6. And what about the coefficient of xz? Xz is minus 4. So it is minus 2. Xz is minus 2. Finally it is minus 4 minus 4. So this is the real symmetric matrix of the given quadratic form. Third, now find out the D1. D1 is the first leading diagonal elements. It is 2. So it is also 2. It is a positive one. What about D2? D2 is, let us extend this for the up to the 2 diagonal. Second diagonal, so 2, 6, 6, 1. So it is 2 minus 12, 6, 36, yes. 36 is equal to minus 34. So this comes negative. So one is positive, one negative. One positive, one negative. Once D2 comes negative, sorry to say this. Once D2 comes negative, the answer must be indefinite because it is all other cases. You see that? All other cases. Once D2 is, however, this positive may be 0. Only two possibility. D2 is maybe either positive or maybe 0. It is well and good. Once D2 comes negative, what about D1 and D3? D1 and D3 is also negative. That is negative definite. But once D2 comes negative, unfortunately here D1 is positive. So positive, negative. This is other than the above cases. So the answer must be indefinite. The answer must be indefinite. So what about D3? When you go for D3, you determine the matrix A by using the expansion of the 3 by 3 determinant. The answer must be 162. Go and check the answer. But I don't want to go for the D3 because of once we get D1 positive, D2 negative. So the nature sometimes positive, sometimes negative. So that is not the defined one. That is not the measurable one. We cannot say about this positive or negative. So once it is going positive, once it is going negative means we are unable to predict the nature. That is called the indefinite. So the third one is an example for indefinite. Indefinite. Very rare case, negative semi-definite and a negative definite. Very, very rare cases. And so the last one, the fourth one, once again the variable sets are x, y, z. So let us find out the real symmetric matrix of the given quadratic form Q minus x square. So minus 1 is the coefficient of x square and plus 1 for the coefficient of y square. Z, x, z. See that z, x. So this is in terms of three variables x, y, z, x. So there are three variables. Q of x comma y comma z. Suppose this z is not there, you may assume that it's a 2 by 2 variables, but here z is present here. So it means that the three variables are there, x, y, z. So what will be the z squared? 0, because there is no z squared appears in the given quadratic form, so it is 0. So what's the coefficient of xy? I think so yx or xy same meaning, so half of that, so 2, 2. What's the coefficient of xz? 4, 4, so y divided by 2 we get 2. What about the coefficient of yz? Yz is not there in the given list, so 0, 0. Now can I find out the d1? So d1 is minus 1. Determinant of minus 1 is minus 1. So once we get negative, it may be negative definite or negative semi-definite. I don't guess the value. I don't guess the nature. Let's say a d2. What's d2? Find out the d2 value. d2 value is nothing but the extension of the 2 by 2 matrix. So it is minus 1, 2, 2, 1. So what's the answer? Minus 1 into minus 1 is minus 1. Minus 2 into 4, minus 5. So this is also negative. This is also negative. So you may think that is it possible to get that d3 is negative? But even though when we get d3 is negative, d1 negative, d2 negative, d3 negative. All are negative means you thought it is negative definite. Sorry. What's the definition for the negative definite? Even the negative definite, d3 must be positive. d3 must be positive. So but here we get d3 negative, d1 is also negative. d1 is also negative. Once d2 is negative, I am guaranteed that the nature must be indefinite. Yeah. So can you check the d3 value? What's the d3 value? d3 values, unfortunately, that is also negative, I think so. Yeah, I think so, because of this coming 0, minus 2, so it's coming to minus 4, minus 4, minus 1, minus 1. I think d3. What's the d3? d3 is coming minus 4 or 0. What is the answer? I think it is 0. Yes, 0. Minus 1, 2, 0. This is 0. That is 2 into whatever it is. We can expand about this one. So minus 1. So what's the answer for this? Negative. Yeah. Let's go for this one. Determinant of A. Minus 1 into 0. Yes. Minus 2 into this column. This and this. And here 0. And plus 2 into this column, and this row is eliminated. So 2 into 0. 0. And minus 2. Minus 2. So in here the answer is minus 4. This is negative. D1 negative. D3 negative is okay. D1 negative, D3 negative. But what about D2? D2 is also negative. So once D2 is positive, it may be called as negative definite. But unfortunately, D2 becomes negative. So this comes under all other cases. This comes under all other cases. So this is also indefinite. So that's why I told you that once D2 may be negative, no problem. Maybe it's positive, no problem, is equal to 0, even though these possibilities are there. But once it is coming negative, then obviously don't think about the D3, guarantee that the nature must be indefinite. I hope everyone enjoyed this concept, you understand this concept. Please go and watch my previous videos, how to convert the canonical form, that is a quadratic form into canonical form, how to get the quadratic form into the real symmetric matrix. Please go and watch so that you can get benefited. And also please kindly subscribe, comment and share to your friends. Those who are doing engineering courses, they also got benefited. Thank you so much for watching our YouTube channel. This is your ADC, signing off ADC Maths. Thank you so much.